This is the last video in section 3.5 on the chain rule. In this video, we're going to use the chain rule again to accomplish what we did before with implicit differentiation. So theorem 3.5.4 is analogous to the theorem that we saw in the previous video. If f of x, y, z is differentiable and the equation f of x, y, z equals 0 defines z implicitly as a differentiable function of x and y, then as long as f sub z of x, y, z is not equal to 0, the two partials, del z del x and del z del y, can be calculated as, so del z del x is minus f sub x of xy over f sub z of xy, and del z del y is minus f sub y of xy over f sub z of xy. Example 3.5.6 says back in example 3.3.2, we used implicit differentiation to find del z del x and del z del y when this function, when this equation implicitly defined z as a function of x and y. And now we're asked to use theorem 3.5.4 as a different method and make sure that we get the same result. So we are going to let f of x, y, and z be z cubed y squared plus y cubed x squared minus x cubed z squared minus 4. The theorem is going to have us use all three partials, f sub z, f sub y, and f sub x. So let's calculate them. F sub x of x, y, and z is, we're taking the derivative with respect to x, so this goes away and so will this. So we will get 2x y cubed minus 3x squared z squared. F sub y of x, y, and z, taking the derivative with respect to y now, we're going to get 2y z cubed plus 3x squared y squared, and the last two terms have no y's in them, and f sub z of x, y, and z gives us 3 y squared z squared. This term has no z, neither does this, so minus 2x cubed z. By theorem 3.5.4, del z del x is going to be minus f sub x over f sub z, which means I'm going to take the negative of this expression and put that in the numerator. So I'm going to get 3x squared z squared minus 2x y cubed over f sub z, so 3y squared z squared minus 2x cubed z, and del z del y minus f sub y over f sub z. So I'm going to take the negative of the f sub y expression, so minus 2y z cubed minus 3x squared y squared divided by the same denominator, 3y squared z squared minus 2x cubed z, and we compare. Do we get the same thing for del z del x and for del z del y? It looks good, so that this is the same here, and this is the same here.